The Jovian planets, such a happy sounding name, sometimes called the gas giants, sometimes called the outer planets. Just like there are 4 terrestrial planets, there are 4 Jovian planets as well. You see they have some similarities. The Earth isn't shown on here to compare with, but the Earth is about 1/10 the diameter of Jupiter. So a little bit smaller than the drawing of this core here. And by the way, some of the things that I'm about to say about Jupiter could be shown incorrect, probably not drastically incorrect, but slightly incorrect, thanks to the most recent Jupiter probe called Juno. Just a couple days from the recording of this, on July 4th, 2016, the probe Juno is going to be entering Jupiter's atmosphere and investigating Jupiter's magnetic field, the clouds of Jupiter, the atmosphere of Jupiter, and learning more about how the sun's particles interact with Jupiter via its magnetic field. And that's going to teach us about the formation of Jupiter, which could teach us a lot about the formation of the solar system as well. I said these are also called the gas giants, and gas is part of it. So gaseous hydrogen here, but there are a lot of other things as well. And in fact, metallic hydrogen makes up a much larger percentage of Jupiter than the gas phase of hydrogen does. They all have the outer cloud layer, kind of a brownish orangish color for Jupiter and Saturn, kind of a bluish color for Uranus and Neptune. All 4 of them have a rocky core. The exact makeup of the core is something that we'll learn more from the Juno probe. A big difference between Jupiter, Saturn, and Uranus and Neptune. Uranus and Neptune have a lot more water, methane, and ammonia in the actual body of the planet. The moons of Jupiter and Saturn have a lot of water, not quite as much methane and ammonia in some moons, a lot in others, which we'll be talking about in a bit. Very little water and ammonia within the planets Jupiter and Saturn. Here's just a close-up of the atmospheres. So notice the band structure in all of the planets, much more prominent in Jupiter and Saturn. And this band structure represents cloud patterns similar to the Earth. These planets all rotate much, much faster than the Earth, and because they're a lot larger than the Earth, their rotation rate per diameter kilometer is a lot greater as well. And these cloud bands go in opposite directions, or the different bands, I should say, go in opposite directions. Some of them are cloud bands on an upper layer, some of them are visions to farther into the planet. They also have storms. The large red storm here of Jupiter is fairly well known. Neptune also has a giant storm as well. And these storms are larger than the planet Earth. So these are storms that would cover the entire diameter of Earth here. This shows Uranus's ring. Saturn, of course, is known as the ring planet. It shows it here, but all of the Jovian planets have rings. I mentioned the cloud structure. Of course, Earth has clouds as well, and the pattern of pressure cells on Earth is governed by the rotation of the Earth. These clouds rotate in opposite directions in the northern hemisphere and in the southern hemisphere. On Jupiter, same sort of thing. You've got the white bands. Those are bands of rising air. So pressure cells on Earth, the low pressure cells, it's lower pressure in the middle and then higher pressure around it. Higher pressure shells are the opposite. Sort of the same thing on Jupiter, except instead of smaller areas like this, which there are some, these storms on Jupiter, but the whole cloud structure has a rotation rate that's observable. Earth also has that same sort of structure. You may have heard of the trade winds, which blew from Europe towards the New World, America, so westerly winds. But below that latitude set and above that latitude set, the winds blow to the east. So if Earth had more clouds, you would notice the same sort of rotation pattern on the Earth. The moons of the outer planets oftentimes are considered to be more interesting than the outer planets or the Jovian planets themselves. I'm going to highlight a few. One of them is Europa. Europa is thought to have a few kilometer thick ice sheet covering it, so the entire surface is ice that's a few kilometers thick, and below that is a liquid ocean, a liquid water ocean. So you might be thinking, how can there be a liquid water ocean so far away? Didn't we read in the book that the outer solar system is too cold to have liquid water and water vapor? It is cold out there, but there is an extra heating source, and that is the gravitational tug of Jupiter. So Jupiter is so large, and these moons rotate fairly close to, or revolve around Jupiter fairly close to it, that the gravitational tug of Jupiter squishes it. I've got a squishy ball here. This actually shows the Earth, but it sort of squishes out like that and in, and that squishing, obviously I squish the ball much more drastically, that squishing creates temperature, just like if you take a paper clip and bend a paper clip back and forth. So I've got a paper clip here. If I take this, and you've done this before, you take it and you bend it and you touch the bendy part, it feels warm. Same sort of thing. That internal heating is what is creating the liquid water here. That's why it's not just all solid ice. Some people think that there are vents at the bottom of this large planet-wide European ocean or moon-wide European ocean that are similar to vents at the bottom of Earth's ocean. They think that there might be life around those vents. Europa has been known to have water, or I probably shouldn't say known, but strongly thought to have liquid water for quite a few years. Have we thought that? Enceladus, which is one of Saturn's moons, that's a fairly recent discovery in terms of a certainty that there is a liquid ocean under the surface. One of the big clues for that is Cassini, which is a NASA probe, has flown around the Saturn system for quite a long time, and it's passed through these plumes. So these represent geysers that are shooting up from Enceladus. And if you look, this represents 20 kilometers, so these geysers are visible 20 kilometers into the air. So 20 kilometers is on the order of about, 20 kilometers would be about 12 miles. So 10 kilometers is 6 miles. 20 kilometers would be 20 kilometers would be 12 miles. Enceladus is much smaller than Earth's moon, so these geysers are shooting up a significant percentage of the radius of Enceladus. And that's because Enceladus is so small, it has weaker gravity, and it isn't going to pull these particles back as rapidly as geysers shooting up from the Earth. Geysers shooting up from the Earth would be much less than 20 kilometers. Scientists want to send a new probe to capture some of these particles and determine if there is evidence for life there. So the Cassini probe has detected amino acids, some of the building blocks of life, but building blocks of life doesn't actually mean life. Just like you have a box of Legos, you just jiggle around a box of Legos, that doesn't mean that there's an actual Lego building in there, but they're the building blocks for those, for that building. The Legos are the building blocks. Amino acids are the Legos to the building, which is made from the Legos. Europa and Enceladus are two objects that have liquid water under their surface. Titan also has liquid, but it's not liquid water, it's liquid methane. Just like Earth has a water cycle, Titan has its own methane cycle. Just like because of our water cycle, water, and if it's a cycle, you figure when do you start? So let's just start with evaporation. So water evaporates from the Earth, and that evaporation rises up into the clouds, and we get those clouds condense, and when they condense out, water falls as precipitation and forms lakes and oceans, which then evaporate, and the cycle continues. Same sort of thing here, but instead of a water lake, this is a liquid methane lake. So the liquid methane will evaporate, rise up into the atmosphere, get methane clouds, methane rainstorms, which will fall back down and will feed the lake again. Cassini has studied methane, and the Cassini probe actually, the Cassini orbiter actually dropped a probe onto Titan, which studied Titan really closely, and that's how we have such good pictures like this. And this is 100 kilometers, so this lake here is on the order of 1,000 kilometers across. Titan is the second largest moon. At one time, astronomers thought it was the largest moon because they were fooled. They thought its thick atmosphere was actually part of its surface. But Ganymede, one of Jupiter's moons, is actually the largest moon. Titan is a close second. Both are much larger than our moon, but much smaller than our Earth. So again, this lake being roughly 1,000 kilometers across, that's about 600 miles across, that would be a very good sized lake on Earth. I'm trying to think, the Caspian Sea is not 600 miles across. It might be 600 miles from north to south. But this would be one of the largest lakes on Earth if it was a water lake on Earth. You have read, and I talked in another video about terrestrial planet geology. So the internal heat of the larger terrestrial planets causes there to be a liquid metal part near the inner area. So Earth has a solid metal core, liquid metal surrounding it, and that produces a magnetic field. But that also produces heat for the mantle, such that the mantle is pliable and the surface is malleable. And that's in part from the heat that's left over from the residual heat, but also from radioactive decay of the metal in the interior. So that causes volcanic activity and tectonic activity, a very active surface. Jupiter's moon Io has volcanoes in the similar sense, although its internal heating source is not radioactivity or residual heat. It's that squishing of the surface which creates the heat. The Jovian moons, they have activity as well, but except for Io, they have cryovolcanism. So they're water, ice, ammonia ice, and so on. That heating again is caused from tidal heating, the squishing of the planet from Jupiter's gravitational pull. Even if that tidal heating is minimal, because you might think, well, this squishing here can't cause that much heat, but the ices that are out there are much weaker, so it takes less heat to cause them to flow and for there to be this kind of activity. Enceladus here. So this surface here is cracked, and that's where these things can leak out. So because there's the squishing of the planet from Saturn's heating, produces those cracks, the heating keeps the water there, and hot water, warmer water that's warmer than its surroundings, is going to expand and shoot out through these crevices. So if you're looking for some beachfront property at a low price, go to Titan. If you want to visit some geysers, go to Enceladus. Europa has some geysers as well. Not quite as many. They're not as noticeable because Europa is larger and the geysers aren't going to shoot up as much. But if you'd like to drill down to an undersurface ocean, Europa is the place for you.